Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Jamalisyawal bin Ambo Miri with ID matrix of TB 210044 for subject Electrical Fundamental Laboratory from Section 01. So, for my final project of this subject, I will be doing a topic about half wave and full wave rectification. So, for this first part, I will be talking about half wave rectification. So, half-wave rectification is a circuit that's constructed in series between the connection of a supply power connected with a diode, which is in this picture we are using S1, and then our loads, which indicated by R1. So, later during the simulation, we will find out that our input signal, showing just like in the figure 1, where we got the negatives and positive cycle, both has a value of voltage up until the V max and V minimum, and it's repeated along the experiment or during the simulation. But later, we find out the output signal will be showing just like in figure 2, where for the positive cycle, we got a value of V max. But for the negative cycle, the waveform turns to be a flat waveform, or it's nearing 0, where the waveform is flowing along on the top of x-axis. And if we compare both signal, just like in figure 3, we can see it's more clearly. For the negative cycle, the voltage produced after the output signal, it's actually 0 volt. And if we're comparing for the positive cycle, the output signal waveform producing V maximum slightly lower comparing to the V maximum that produced or we use from the initial impulse signal. So let's go and see how exactly the truth of this through the simulation part. So this is the construct of the circuit, where as you can see, I'm using a voltage source of AC voltage, alternating current, with a voltage peak of 10 volts, and I set the frequency to 1 kilohertz. And then I'm using a diode of S1, switch 1, which it will have voltage drop around 0.7 volts. And then for the loads part, I'm using resistance 1 with a value of 1 kilo ohms. And then I connected our circuit or our rectification circuit, rectifier circuit, with a Textronic oscilloscope. The ground of the oscilloscope must connected to the ground of the circuit. And then for the first channel, which later it will showing a yellow waveform, connected to the voltage or the voltage and the current supply from our going out from our supply. And then for the second channel, later it will showing a blue waveform, is connected, showing the waveform that produced after the rectification process, after the voltage and current flow throughout the diodes. So let's run the simulation. So as you can see here, this is our waveform, which is the input signal. So we zoom in first, and then we change the volt for division to see the voltage value clearly. So as you can see here, for the positive cycle, we got a value. If we measure it, the V maximum is 9.98 volts, while for the negative cycle, the V minimum is around negative 9.98 volts. And if we run back later and we set for the channel 2, and then we change the volt per division, we set it to be like this one. So we turn off the signal input. Then you can see the waveform produced after the rectification totally changed, where for the positive cycle, it's producing a waveform, but for the negative cycle, it's almost nearing 0. And if we measure for the channel 2, for the maximum voltage, it's turned out to be 9.28 volts, which is it's less almost 1 volt comparing from the signal input. And then for the minimum value for channel 2, it's negative 1.07 millivolts for the V minimum, where it's nearing 0. So how this happened? Let's look back on our slide. So this is the measured value that we gain from the previous simulation, where I already state all the type, start from frequency and up until the period. But we're just going to look for the type of frequency, voltage peak to peak, cycle RMS, maximum minimum voltage, and periods. And you need to know that after the observation that we see, for the half wave rectification, voltage peak to peak output become half from the input, and then the cycle RMS is slightly half from the input or the output, and then for the maximum output is slightly less, almost 1 volt comparing from the input that we enter inside the circuit. And then for the minimum, our output slightly producing voltage that nearing 0, which is it was negative 1.07 millivolts. And then for the frequency and the periods, it remains same. So how this happen? Let me explain. So rectification process, actually we define in two cycle, which is positive cycle and negative cycle. So for the positive cycle, as you can see inside of the figure 4, during the positive cycle, our voltage and current will flow through in a clockwise direction, where the current flow from the positive terminal of our V1 going through to our S1, where you need to know that S1 terminal positive is on the left, and for the negative terminal of S1 is on the right. So in this situation, our diode actually functioning in forward bias, where it's allow current to flow within it. Then our current will continue the flowing until our resistant one, which is our loads, and finally end up meet at the negative terminal of our V1. So here the connection is completed, and that's why we are able to producing voltage at our output, at our loads, where as you can see in figure 5, for the positive cycle we are producing a waveform up until the V maximum, and then from the previous measured value we do find out that the V maximum is 9.28 volt. But if we comparing from our input voltage maximum from our input signal, it's slightly less, which our input signal voltage maximum is around 9.89 volts. And then if we minus both of those value, we can actually gain the voltage drop, which is after the simulation we get the voltage drop around 0.6 volt, which is it's nearing the differential voltage drop of our S1, which is 0.7 volt. Then we go to the second cycle, which is negative cycle. As you can see in figure 6, the direction of the current flow and voltage is actually in clock or in counterclockwise direction, where the current flow from the negative terminal of the V1, and then it meets our loads first, and then it ends up blocked at our S1 or our diode. You need to know that diode is actually a electrical component that only allow current to go through within one direction, which is the direction that allows is from positive terminal to negative terminal. But in this situation, our current cannot penetrate our diode because here our diode acted in reverse bias, so the current cannot flow. So when the current cannot flow, then our circuit become an open circuit. So when there is open circuit, then the voltage value will be 0. That's why, as you can see in figure 7, the waveform turns to be flat on top of the x-axis with a value of 0 volts. And that's explaining why our waveform, after the rectification process, it turns out to be on the positive cycle we got a value of the voltage, but for the negative cycle it turns to be 0. Later, we will continue for the part 2 for the full wave rectification.